New digital technologies are driving a step change in enterprise business transformation. At the Digital Twin Podcast, we explore the intersection of technology and business. What should your digital twin look like?
Welcome back to the Digital Twin Podcast. Your host, Omar Hari. By popular demand and feedback from our customers, Hari was mentioning the other day, our audience has been saying, what's up with the name of our podcast?
That's right.
Am I right, Hari? I
That's
mean, we've
right.
been getting a lot of mail on that. What's going
So
on with that?
we have Digital Twin Podcast as the name, and obviously it's what we use for our Twitter handle, YouTube, and the website, and so on. And so the question is, what does it mean, and why did you even name it Digital Twin? Are you digital twins? Are we the twins? What's this about?
Yeah, that was one of the funny commentary. They were digital twins there for something. They were really trying to figure that one out, right?
Yeah.
Uh, but yeah, I think it's a
Hey,
good
we're
point,
physical
and
twins, maybe? No.
yeah, I think we
We
aren't
aren't physical twins
hybrids
either.
or cyborgs or anything like that, right? No, but I think it's a valid one, and I think most people in this space around digital transformation, IoT, have probably heard the word come up a little bit, and there's multiple definitions of what people think it is, but at the end of the day, it's the core of how you actually benchmark or put, a digital component around um, physical operations or physical assets or physical anything out in the world. I mean, how do you actually benchmark it, get a digital signature so you know where you are from a digital point of view? That's really what we're talking about here. The core of really putting a framework and a skeleton around what you're trying to measure or benchmark. And it could be a variety of different things, right? You
Yeah.
can look at things as small as, pieces of equipment, overall operations, supply chain. There's a lot of different variations of how you can model or put a digital twin around this to give you some better insights, right? And it's a very complex term. A lot of people have their own definitions of it, but it's quite in a simple way, you know, you're just putting a framework or a box to understand if it's performing the way you want it to or not, right?
So I was looking at the name itself, doing a little bit of research around the origins of the name. It turns out the concept itself has been around for about 30 years from a book that was published in 1991. But then the name, the digital twin, actually came about in 2010. That's when it was first published by
Oh,
NASA.
really?
Yeah, NASA. But since then, obviously, it's been very actively used. There's been a book written around digital twin. And so since then, that's kind of really taken a life on its own. And as you know, the topics that we're most interested in around digital transformation and, what changes, what is it that digital twin brings to the digital transformation game is what we're most interested in. Obviously, we found this to be central to everything digital. We found this to be kind of the future of what we see in a lot of the industries, whether you talk about uh, automotive, whether you talk about industrial, large equipment, you're talking about, automation, you talk about airlines, all of these, the digital twin concept is really taking a life on its own, right? And so, what I want to ask you, in general, I've heard this a lot. How is it really going to impact a digital transformation initiative? What's the role of a digital twin? And if this is a CIO or a CEO or COO wanting to know, how can that change or how can that influence my initiatives around digital transformation? What would you say?
Well, it's quite a loaded question
Yeah.
in a sense, right? Because you're asking, is there a digital twin one fits all, right? In reality, it's not. The way you would envision a digital twin is it's a model or a framework that's built up of components that takes raw data or data that you have that's available, that's bringing it into this model to actually quantify, maybe even put together some benchmarking around what is happening in the physical realm. It can be, I'll give you an example. If you look at IndyCar racing, they put a digital twin around, if they're, you know, Indy 500, 500 laps, right? Every lap is being monitored as a as it's digital representation of what they did. It's video feed, but they're looking at that time trial over and over again and figuring out where the driver or the vehicle may have had some complications in certain areas of the track or certain areas within the vehicle itself. Now, without having some type of representation, a digital twin around that, you wouldn't be able to tell where these anomalies or these variations are starting to happen. That gives you an example just in realm of
So
everyday
that's
NASCAR,
really, if I were to
IndyCar.
summarize, you have a virtual environment that represents exactly what's happening out in the field, and it's reflecting issues, challenges, problems, as well as potentially identify advantages where they could focus on that would make this, would be potentially better, right? So looking for,
Exactly. So I think,
yeah.
yeah. So I think in the first level, what you're going to see is from a twin or digital twin or representation of a physical um, asset operation, is you're going to want to know, is it performing, right? You know, is it doing what it's supposed to do, right? That's the very first level, right? Yes, it's on. Maybe you could talk about, is it on? Yes, okay. Now it's on. Is it performing the way I want it to? So you put boundaries or around that model about this is the way it's supposed to be performing. Am I in range or am I out of range? That's your second layer or fidelity within that model of twin is when we start talking about digital twins. You can have it as simple as letting you know whether things are working or not working,
It's beyond
or if
just
they're
monitoring,
working.
is what you're saying.
Yes,
Yeah.
it's absolutely. So the fidelity of a twin, how much um, data you bring into this twin, the frequency of it highlights where things may be. You have a better idea of where you know things might be off, right? If you like, I just gave you the example of the IndyCar. It could be that he was off on the track. It could be that he didn't turn correctly. It could be that he didn't pedal correctly. It could be the engine didn't fire on the right piston. There's a lot of things that tell you why things aren't performing the way they are. The more data you bring in and the more you represent in a digital twin gives you better insights on figuring out how to quickly identify where you need to focus those efforts. And that's really the heart. If you think about how you can use data, digitize that, and in somewhat of a near real time, really understand where to focus to get better, to get back
Yeah.
to where you need to, or where you might be missing.
Yeah.
That's the edge.
So
That's the competitive advantage.
yeah, so you're referring to the performance model essentially, not just pure, data. You're really looking at the overall performance, whether that is, the performance of the car, or you're making predictions based on the past into the future. All of this combined is really that model, right? Now, there's a lot of confusion out in the field around, is digital twin like a model, a picture, a three-dimensional drawing that somehow looks really nice? I can turn it around and it shows me labels and things like that. And then you put data on top of it that would constitute as a digital twin. What would you say?
I'd say yes. I mean, that's a visual representation of that physical asset. You know, we use data to interpret that. The first level of digital twin, you can look at the laps and you look at the vehicle and you can see that that's also representing, the video feed of what was going on with the vehicle. And that's a visual representation. You can kind of see visually where things might be off. or you can just look at the data and have the data tell you where things might be off, right? So in a lot of cases, you know, people are very visual. You know, if you're walking into, let's just give you an example. If you're walking into a manufacturing facility and you want to know how your facility's performed, you pull up some augmented reality is what, some people are using as a digital twin to give them a digital representation on how you know, their manufacturing floors are actually operating today. They pull up this 3D representation that's bringing data in right away, giving them quick analysis where they're at on what's happening and what's in front of them, right? From a digital standpoint.
Yeah.
People say, well, why can't you do that in a control room? You can, but now you're bringing all that data that's being virtualized inside your control room in front of you in real time.
Yeah.
So
So
that you
what you're
can kind
saying
of
is
troubleshoot.
it could be one piece, it could be many pieces in a holistic environment, like an entire factory, a plant, an entire aircraft. In fact, I've even heard initiatives around creating a digital twin for a human body from a health perspective. They
Absolutely.
look at a digital twin of a heart to better
Yes.
understand how that's performing and what changes would make things better. So the digital twin concept itself is self-updating, right? It's getting information from the real world and it's updating itself, but it's also making its own determination about some things that it can do. Its real life twin could do better because the digital twin has the ability to make certain analysis, predictions, and say
Assumptions.
with a certain level of confidence that, hey, my physical twin could do better if you tweaked this or that, right?
Absolutely.
Yeah.
And I'll come back to that IndyCar analogy again. We had a digital twin of how that performed. You just made a digital twin of the human driver.
Mm-hmm.
His heart rate goes up after every turn or after he's got a car on the side of him. Why is that? Is he comfortable with that? Do we need to involve the next practice session to get him more comfortable so that he's able to handle these different turns or this
Yeah.
situation differently to enhance the performance, just like you're saying? So you're right. The way that you can model or digital twin, put a digital twin around certain aspects of what you really care about monitoring
Yeah.
or seeing the behaviors of is quite vast, especially when we get into the world of IoT with sensors and data all over the place.
Yeah.
You can almost model or put a twin around almost anything.
So
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 it's
we've
very vast.
yeah, so we've identified like maybe two or three elements here, right? One was the sensor or data that's coming from multiple systems. Could be from one sensor, many sensors, many systems. You talked about the communication aspect of it, uh, human aspect of it, right? You got the car and the driver, so there is the human interaction aspect of it. But then there is also the SME knowledge. What does the driver know that can go into the model, right? The driver has specialized knowledge that could be input into the model that could then make that model much better. And that's true whether that's a car, the plant, or a plane, or a human body. What a doctor
Exactly.
knows has to go into the model, right? Would you agree?
Yeah, and I think that is a very solid point. I think you there's a balance here with the model, and I use it as the fidelity of the model. How good do you want that model to be, right?
Mm-hmm.
The more data, the more things you start to model, the more, extensive and rich the model becomes. But at some point, the human element, it's very difficult to mimic or put together a model of how the driver takes that turn to know exactly how much friction is coming off of that left tire,
Yeah.
right? Or how the weather affects that left tire on that turn on lap number 12 after pit stop, right?
Mm-hmm.
He has that information. He knows how far he can push it. Now, yeah, it's great to kind of maybe we can bring that into the element of the twin, but at some point you have to kind of give yourself some room there for, that flexibility so that your model doesn't start to become so complex and so rich that, you know, bad data that might come in and affect it may throw the whole model off in general. So
Yeah.
this is the balance. This is
Hmm.
the balance between what is good data, what data you need to bring in to have a robust modeling or digital twin around what's really important,
Yeah.
right? So it's a very valid point. But the answer is yes. You can add as much as you want. Now, sustainability and maintaining that model moving forward will become a challenge as you start to really invest a lot of
Yeah.
very specific and very high velocity of data. So you have to be very, it's a balance. It's a balance, I would have to say, at
So
the
the
end.
human element could also be the fact that there is tribal knowledge in the plant or in a hospital that is
Yeah.
probably not documented well enough. It could be just, based on experience, right? And how do you really get that digital and get how do you make that part of the overall digital infrastructure? Right? That's the
Yeah.
part that I believe the humans can add a significant amount of value, right?
Yeah, it's a very valid point, and I think you can do that with a mixture of SME knowledge, but you can also put some data-driven modeling around that, right?
Mm-hmm.
Not everything, not every piece of asset, equipment, or operation runs the same way, but if you can model that over time
Yeah.
and know where those variances are by SME knowledge, people that do it every day,
Yeah.
you can add that into the model to say, hey, it's not off. This is just the way it's been running.
Yep.
And you can ask yourself, should it be running that way or should we actually fix it? And start analyzing whether you need to adjust your current operations or your current conditions to operate better. How you actually pull that into your actual digital twin is going to really dictate how much variances you can actually get away with. Find the constraints or give you more throughput where you might need it. So you're absolutely right. The SME knowledge comes very handy, especially for digital technologies that need to be adopted in certain areas. You bring
Yeah.
in that SME knowledge within that digital infrastructure, you have a higher adaptability, which is a very big deal.
You
So
also hinted on another area, the fidelity of the model, right? There's always this balance of how much effort and cost goes into building a model and how much value do you generate out of it, right? Um, in some cases where there is a management of the entire product life cycle where you have the ability to see the concept to design to production and then get the feedback of the instances of these digital twins out in the field and have that data come in and make your digital twin better, more I would say better from a production perspective. You can change your designs, you can change your manufacturing methodologies, etc., to make a better twin instance out in the field, right? But at the same time, there may be instances and applications where the effort to do a high fidelity twin may not be worth the value that you're going to generate from it. What's your take on that?
yeah, I think that's a very important case. A lot of times people get um, caught up into the hype of we have to do this because
Yeah.
everyone's doing this. But in reality, you need to really be strategic, right? This is where, having a good digital strategy around what's important, what you really want to get better at
Yeah.
becomes a very vital piece before you start putting twins over everything, right? Does it make sense? I'll come back to the race car. Does it make sense to put a twin over the track? Does it make sense to keep putting a twin over the vehicle? Do you want to put it over the engine? Do you want to put it over the gas pedal,
If you
the
make
brake
enough money,
pedal?
you can.
The driver. You make enough money and you want to look at
Or you
each
keep the driver
individual aspect?
safe, you can.
Yeah. So there's a lot of different pieces and modeling that you could add into this, but at some point you have to start to ask yourself, is this work actually generating more value,
Yeah.
or am I starting to see the diminishing returns as I get to a certain point, right? So
Right.
yeah, that's the balance that I keep talking about, that people need to really understand where that convergence is so that you get the best out of the your twin and modeling. So that's a very valid point, and it's a very one. It's one that gets missed off pretty often in the very beginning stages of a transformation. Um,
I
everyone's on the hype style. So
Yeah. I think we give a pretty good introduction to why we chose the name and some of the reasons behind it. We do have a mind map around some of the things that we talked about. Of course, if you go to the YouTube channel that we do have this screencasted as well. So feel free to check out the YouTube channel for Digital Twin Podcast. Of course, you can also check us out at digitaltwinpodcast.com or Digital Twincast on Twitter. Feel free to send us a note, questions, comments, or any suggestions on any future podcast topics you'd like.
All right. Well, I appreciate it. And y'all have a safe evening. And till next time,
Be safe. Take care.
be safe.